So now, after we made some estimation about the coordinates of these points, especially the ones that occurring not on the exact cross lines, we just did an estimation using a ruler and also using the information that we can get from these points. Now we set the points. As we see here, we define the points by naming the x coordinate first, then the y coordinates for naming each point. Let's move to the second question. What is the distance covered at t equals 6 seconds? We can answer this question in two ways. The first thing, we can directly say that, okay, here we have 6 seconds and the direct distance covered is 40. As we can directly see from the distance graph, the distance, it was 40. Or we can see from this point that the distance covered using the velocity time graph, it's supposed to equal this area under the graph for anything that is laying down from time 0 to time 6 seconds. So by calculating this area, we supposed to have the same covered distance, which will be equal to 40. Tamam? So we can directly answer from this graph, or we can calculate the area under the graph for velocity times graph, which is supposed to be equals to 40. So now I calculated the area under the graph from time number 0 to time number 6, and actually it is equal to 40, just like we are supposed to obtain. We can see that this area, the area of the rectangle, it is x multiplied by y. So in the x-axis we have 6 and the y-axis we have 4. So this is 6 and this is 4. So by direct multiplication we have 24. The same case applies here. Here from time number 4 to time number 8, we can have 4 in this axis and also 4 in this axis. From 2 to 6 it will be also 4. So the area under the graph from t0 to t6, it will be equal to the sum of these two rectangles, and it will be equals to 40. Tamam? It is equal to 40, which is the same that we can directly obtain from this point just by see the direct distance that we have from this, and it will be equal to 40. So because we are talking about two graphs of the same moving object, so let's answer directly that it will be 40. Okay, what is the velocity at t equal 10 seconds? They asked about the velocity, so we can obtain this directly from the velocity time graph. We can see that the velocity at t equal 10, we have 2 points, okay? We have point at velocity equal 12, and because it was a turning point, or it could be also 6 meters per second or 12 meters per second. To make sure about the exact velocity, since it was a turning point, let's go to this t equal 10 and calculate the direct speed or instantaneous speed just by calculating the x-axis and the y-axis. In the y-axis we have 78, and in the x-axis we have 10, which means that the speed or the instantaneous speed, okay, so let's write it. Okay, the velocity at t equal 10, so directly we will put the instantaneous velocity law, which is distance over time, and for the distance we have almost 87, and for the time it was 10 seconds. So approximately, because this is a turning point and this is an instantaneous speed, the velocity, it was 8.7 meter per second, because this is an instantaneous speed. So we cannot directly get the instantaneous speed for the turning point at t equals 10, because we can see that 10 is a turning point. 10 is a turning point. So we have this point and we have this point. It was not a gradual acceleration. If it was a gradual, if it was a gradual acceleration or gradual speeding up like this, we have a constant speed, which means acceleration is 0 for t equals 8. We can directly tell that the velocity at t equals 8 is 12. It will be really direct. But for the turning point, it will not be direct. We're supposed to obtain this information from the distance time graph by calculating the instantaneous velocity. Okay, between which time intervals is the object at rest? So when they asked us about object at rest, it means that the object is not moving. So we can see that we don't have any straight lines in the distance time graph. So there is no interval for the object not moving. During all the intervals, the object was moving. So the object never stopped. So we can say that there is no interval. But if we have a straight line in a velocity time graph, it means that we are moving in a constant speed. So it is really important to emphasize on this. So we can say no interval. Calculate the slope of a distance time graph between t number 0 to t number 2. It will be really direct. So the law, it will be slope y2 minus y1 over x2 minus x1. For this case, y2, it will be, always define the point so that you will not be confused. This is x2 and this is y2, and here this point is 0, 0. So this is x1 and this is y1. So it will be 8 minus 0 over 2 minus 0, which will be 4 meter per second, which is equal to the velocity at this time. Calculate the slope of a distance time graph between 2 to 6, and let's calculate. Okay, tamam. So this, it will be x1, y1, and this will be x2, y2. Let's calculate the slope. The slope, again, it will be equal to y2 minus y1 over x2 minus x1. So let's start with the y-axis. It will be 40 minus 8 over 6 minus 2, which will be 32 over 4, which is 8 meter per second. So we can say that it is the same speed obtained for this duration, which is 8. So by this we can ensure that the velocity we calculated, or the slope we calculated, it is really accurate on the same interval which is the same interval that we calculated for, which is from t number 2 to t number 6. And here again, from t number 2 to t number 6, we can from the velocity graph, the exact speed directly from the graph t ordinates, we can see that the direct speed, it is 8 meter per second, directly obtained from the speed time graph. Compare the slopes from t number 2 to t6 to t10 by observation without calculations. Okay, if we compared this line to this line, which one have a greater slope? The one with the greater slope by only observation, not by calculation. We can see that the line that is really near to be a horizontal, this is a line with a slope, صح? Let's say if we consider this is a line with a gradient. So if the line it was less gradient, it means that the slope is less. We can see that this is less gradient. In another way, if the line it becomes more horizontal, it means it's less slope. If the line becomes more like a vertical, it means that the slope is higher. تمام? Is greater. So if the line is almost horizontal, it means that this slope is much less. So we can see that this slope is much less, only by observation, less slope. And this is greater slope. And this is less slope because it is more, it is more near to reach the horizontal state. So this is less slope. What do we mean by less slope? It means also less speed, and also this is higher speed because the slope is higher. This is just by observation. If it's more near to be a horizontal line, then the slope is less. If it's more to be a vertical, it means that the slope is greater. تمام? Less slope, it means less speed. And this is the exact information that this question is asking about. So we can directly answer this when they asked about the observation without any calculation, which shows faster motion. Of course, from T6 to T10 shows greater slope, so that greater speed. And how did we know that? Because this line is more near to be a vertical, not a horizontal, while this line is more near to be a horizontal. Like this line is more like a horizontal and this line is more like a vertical. So if the line is becoming more vertical, it means that the slope is greater. Question number 9. Calculate the acceleration from the velocity time graph between 0 seconds to 2 seconds. We can see that we can calculate the acceleration only by calculating the slope. So if we calculated the slope at this point, let's calculate it. I told you that for any horizontal line, the slope it will be 0. So they asked us about the acceleration. So the acceleration equals to the slope of velocity graph. So let's calculate by defining first the points. This point is 2, 4, and this point is 0, 4. So let's calculate this. It will be x1, x2, this is y1, and this is y2. So y2 minus y1 equals x2 minus x1. For y1 and y2, they are equal, which is 4 minus 4 over 2, which is x2 minus 0. So it will be 0 over 2, which is equal to 0. So that acceleration is 0. What is the unit of acceleration? Is meter per second square. This is the unit of acceleration. Calculate the deceleration. Deceleration is the opposite of an acceleration between T10 to T14. This is T10 and this is 14. And since the question asked us about the deceleration, it means that the speed is going down. Again, we need to calculate the slope. So this is y1, no, this is x1, y1, and this is x2, this is y2. Since it is a horizontal line, it also shows that the slope is 0. So we can tell directly that the slope is 0, so that the acceleration is 0, while the velocity is a constant velocity and equal to 6. But I want to make the calculation so that you will not be confused about anything. Again, the acceleration is equal to the slope at velocity graph and it equals to y2 minus y1 over x2 minus x1. For y2 it is 6 minus y1, which is 12. No more y. Yes, this one is 6 and this one is 12. So it is, okay, it is 6 minus 12. Sorry, for this point, because we are calculating the slope for this portion, so this point it will be 10, and this point it will be 10, 12. So if we are calculating the slope at this point, we're supposed to consider this as this is x1 and this is y1, and for this point it is 14. So this is x2, this is y2, because we are asked to calculate the slope of this line, not from this point to this point, okay? So again, we will reconsider this again. We have y2 minus y1, which will be 6 minus 6, not 6 minus 12, over 14 minus 10, which will be 0 over 4, which is 0 meter per second. While if we calculated this slope, it will be the slope of this line. But in this case, if the object was having a deceleration or a gradual slowing down, like if there is, let's make that this is an imaginary line, tamam? This is an imaginary line situation. If the object was moving down gradually, not in a drop line. So if we are asked to calculate the slope of this line, the slope, it will be equals to, this will be x1 and this will be x2. So y2, which is 6 minus 12 over x2, which is 14 minus 10, so it will be minus 6 over 4 meter per second. So the acceleration in this case is minus, which means that the object is moving down gradually, if this is an imaginary line, tamam? But since this line is not appearing and the moving from speed 12 meter per second to speed 6 meter per second, it was an instantaneous moving down or an instantaneous drop. It was not a gradual drop. So that the acceleration is 0. But if it was a gradual slowing down, the acceleration, it will be minus 6 over 4. Which section of the velocity time graph showing a constant velocity? Which means which portion of the velocity time graph is showing horizontal line, because already told you that any horizontal line, it is showing a constant speed. So this is a constant speed because this is a horizontal line. This is a constant speed because this is a horizontal line. This is a constant speed because this is a horizontal line. This is a constant speed because this is a horizontal line. while this imaginary line is not a constant speed. It is a gradual slowing down, so it shows that we don't have a constant speed this point. We can see that the object is slowing down. So to answer this, we can see that all of the graph. Find the area under the velocity time graph from t number 0 to t number 6, and what does that represent? We already calculated this by calculating the area under the graph, and it was 40. And the area under the graph for the velocity time graph, it does represent the distance covered, but we need to be more specific. Distance covered at which time exactly? From t0 to t6, just for the first 6 seconds, we mean. Find the total displacement from 0 to 4 using the area under the velocity time graph. So I will just make a comparison between the results that we will obtain from the velocity time graph and if we are being asked to calculate the displacement from the distance. Okay, so if we are asked to calculate the distance from, or the displacement from the distance time graph, it will be much easier. Why? Because we can just have 14. They asked us about the total displacement at second number 14. So it will be the direct point, which is 110. So the total displacement, it will be approximately 110 meters. So this is the total displacement. Just to make sure, let's do a calculation here. And don't forget that this is an estimated point, that we made this point by estimation. So let's see if our estimation for this point, it was true or not. Okay, they asked us to calculate the displacement from a velocity time graph. So then we are supposed to calculate the area under a graph. Okay, it's a direct rectangle for this portion. So here we have 4 centimeters. And here we have 12. So the area for this portion, it will be 12 multiplied by 4, which will be equal to 48. And let's calculate with another color. This is 4 meters. And this is from 0 to 6. So this is, okay, so 6 multiplied by 4, so it will be 24. Now let's add all of the areas that we have for under graph. Let's highlight what results do we have right now. We have 16 for this portion. This portion is 16. Tamam. And this portion is 24. Tamam, this portion is 24. This is also 24. And we already highlighted this in blue. This is 24. And this is 48. All of this area is equals to 48. Tamam? Okay, now let's do a direct calculation. We have 1, 2, 3, 4. We have 4 portions of the area under the graph. So let's see that the first one, it was 24 plus 16 plus 48 and plus 24. Okay, let's use the calculator. 24 plus 16 plus 48 plus 24. It is 112, which is supposed to be the same since this point is an estimation at first. So we can tell that this point, it is 112. It is not 110 as we previously estimated. We can see that we estimated this point a roughly estimation. So by this we made sure that this point is 112. It is not 110. But also this shows the accuracy that we already, when we estimated this point, it was really accurate. Because we estimated this point as 110, and it was really near to the accurate estimation, which is 112. So by this we can, let's say if this was an anonymous value like x or y or k or any constant, that if this was an anonymous number and I asked you what was the total displacement and please identify what is this point, you can directly calculate the distance that we have under the graph, just like the ones we did here. So we can tell that this point, the exact coordinate of this point, so actually the distance from both of the graphs, it should be the same. If we obtain the distance from the graph, it will be directly read by the distance, the maximum distance covered, which is 112, and it is supposed to be equal as the distance under the graph of the velocity time graph. Because in the velocity time graph, we are supposed to calculate the area under the graph, and the area under the graph, it is equal to the distance traveled. Tamam? Okay, compare the total displacement obtained, and we already did the comparison, and yes, they are equal, and they are supposed to be equal always. So by this should supposed to be 112, not 110. Okay. Question number 15. Explain how the slope of the distance time graph is related to velocity time graph. I already explained this to you. Like the velocity, the slope of the distance time graph is equals to the speed we are obtaining here from the velocity time graph. Like from this portion to this portion, we can see that the slope here is equals to the y-axis here, because this is the velocity. The same case applies here. The slope from T2 to T6 is supposed to be equal to 8. The slope from T6 to T10 is supposed to equal to 12. The slope from T10 to T14 is supposed to be equal to 6. Tamam? By this we answered this. Explain how the area under the velocity time graph is related to the distance time graph. We already explained this, telling you that we can calculate the total displacement of the object by calculating the area under the graph, and it's supposed to be equal to the y coordinates we have in the distance time graph. At what time does the object cover the largest distance in the shortest interval? It means, in another way, that which one of the intervals have the greatest area under the graph. Both of the two questions are asking for the same information. Like they are asking you, we have here many intervals. We can directly say that this interval from T6 to T10 is the maximum, but to make it an equal comparison, let's cut this graph in a direct intervals. Okay, like to see the distance traveled for each interval. Already for this is calculated, which is 24, this is 48. For this, it will be, this we have 16 plus, I want just to calculate this, so this it will be 4 multiplied by 2, so this is equals to 8, so plus 8, so it will be equal to 24. The total for this, it will be 24 for this time interval, and for this time interval it will be 2 multiplied by 2. So for the time interval from 0 to 2, the total distance was 4. From time interval to 2 to 6, the total it was 24. From this time 6 to time 10, it was 48. From time 10 to time 14, the total distance, it was 24. So to answer this question, we are searching for the greatest area under the graph for each interval, and we can obviously see that the greatest area under the graph, it lays down between T6 to T10. So to answer this question, we can say directly it is from T6 to T10. At which time does the object cover the largest distance at all? At all, it means what is the total distance? At which time the object covered the largest distance at all? It's like asking at which time the object covered the largest distance. Of course, this question for any graph, it will be the exact point when the object reached the final point, or when the destination was reached. And when we can see that the destination was reached, it was exactly at time 14. And the total covered distance, it was 112. So the answer, it will be at T equals 14 seconds, where the covered distance is 112 meters. By this, we finish the third exercise.